Okay, let's go. So, hey everyone, my name is Gabor Varadi. I've been an Android developer since about 7 years ago, and I have been an advocate for single activity apps since 2016. So, I think that's been 5 years now. And since then, there were quite a few iterations of how to do things and whatnot. Like Square made Flow at the time, then it was like abandoned. Then I tried to uh, take it over to some degree. It wasn't that great. And then I started working on SimpleStack, and SimpleStack has been developed since like 4 years ago, and it was progressively updated more and more and more. So this time there's a talk about it, showing you and trying to convince you to at least go for a single activity approach. But if you want, then you can use SimpleStack. So yeah, let's see how we can simplify Android development. If I switch to the presentation, it actually switches when I press the buttons. So what is the problem we are trying to solve? We are trying to solve many problems. But most importantly, this is the category of it, navigation and scoping. So we want to know where we are in the application right now. We also want to be able to, like, when we press the back button, then go back to the previous screen. We want to be able to move between these screens, pass arguments between them. We want to have animations as we do that. We want to be able to retain the navigation state across both configuration changes and process that. We also potentially want to know how to pass results between screens. Like when you're done with an operation, then you want to pass something back as a result. And there's, depending on what you use, like either activities, fragment, Jetpack Navigation, or SimpleStack, or something else, they always have some way of doing this. We want to have classes that are bound to the lifecycle so that we are aware of how the state of the application changes over time, and potentially, although not necessarily, because this is kind of shady in some approaches, but we might even want to do data sharing. I used to have deep linking on this slide, but then I had to cut it. So if anyone wants to Q&A it later, I will answer, but it will not be in the slides directly. Okay, so what we need to know is that in 2018, the Google Android team said that they are releasing Jetpack Navigation because activities are the system provided entry point and blah 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 blah. The important thing here is that navigation component is a framework for structuring your in-app UI with a focus on making a single activity app the preferred architecture. This was 3 years ago. And what's also interesting, 6 years ago, Diane Hagborn from the Android core team said on Google Plus, so this, you cannot even find this anymore, only on web.archive.org. But Diane Hagborn was one of the core designers of the platform internals and the designer of activities and whatnot. So you can trust what Diane said about this. So yeah, the activity is an entry point to the UI, and they originally did not really care how you organized the flow. You could either make it one activity with manual changes to its view. Imagine this. This was 6 years ago. Diane said that this is an option. You could also use fragments, which were considered a convenience framework at the time, or split it into additional internal activities if it actually helps you. And as long as you are following the high-level contract of an activity, it launches in the proper state and saves restores in the current state. This parenthesis was not added by me, by the way, this was always there. It doesn't matter to the system. So what is the activities high-level contract, right? Like if you have a navigation, you have multiple screens and you navigate between them, then even though you might expect that the splash screen starts first, it won't after process that. You will restore on the screen where you put the app in background, and this is integral to the contract, the high-level contract of an activity that it has towards the system. And the reason why I'm pointing this out, just like last time, is because there are often these custom navigation solutions that claim that you don't need this anymore because Jetpack Compose will save us. Instead, you will have a singleton list that stores everything. Don't. That's not how activities work and not how Android applications were designed to work. You need to handle the case that you return to the detail, and then as the first screen that is showing, and then when you press back, the user expects to go back to the list. So let's add more screens because 3 screens are not a lot. So let's say we have a splash screen. That's what starts. That's what starts with the application. And I know that a lot of people say that you don't need splash screens for whatever reason. We always end up needing one, mostly to like check if you should go to login or to like you are authenticated. And even if you were to restore on the list or detail, then you can be like logged out forcibly and be thrown on the login anyway. But the splash screen is convenient in this regard. So we have one. And it's also a really nice example for things that Jetpack Navigation claimed that it cannot do, but it can, and we will see that later. So what we have here is a login, an unauthenticated scope in which we have a login flow, like an authentication flow, and once we're authenticated, we have a main screen from which you can, like, I don't know, press a button, go to a list, and then from there go to a detail. Let's move around between them, shall we? So we have these two simple screens. We are just navigating from one to the other. With activities, back in the old days, you would define your new intent as like a static function. You would give it the arguments and you would put them into the intent as intent extras. And in this case, the intent extra had, put extra had the overloads to like know that, oh, this is a string, a supported data type, this is a parcelable supported data type, and you would add them with the string keys. And on the receiver side, you would use get intent dot get string extra, so the receiver would need to know what type it is that it's retrieving and use the same key. And when you want to navigate forward, then register one activity would just say that start activity register to activity.new intent and pass in the arguments. I also have transition there just to make sure that we see it. It was quite common if you were not using Windows styles to use override pending transition after either start activity or after finish in order to override the current transition. In the case of Jetpack Navigation, we first need to explain how Jetpack Navigation works. So in Jetpack Navigation, you have a nav graph, which is like you are within a navigation tag, and inside the navigation tag, you have destination, well, technically nodes. And these nodes can either be other navigation tags that contain other nodes or destinations. And when you want to move from one node to the other, then you define an action. And this action here defines that to move from registration 1 to registration 2, we have this action that goes to registration 2. It has these 4 parameters for how to actually crossfade between them. And we would define the arguments with these XML tags saying that the type is string, the name is arg1, and it's not nullable. And on the receiver side of things, we also need to declare these arguments on the fragments so that you are capable of retrieving these arguments through nav-args. So in order to pass them from the action to the fragment, you need to duplicate these tags with all the types and all the nullability information. And yeah, for this to work, you define this fragment destination and you give it the fully qualified name of the fragment. And when you actually want to navigate there, then you find an F controller, which comes from an F host fragment, and you get this generated class from the SafeArgs plugin, which contains this action that from within this navigation tag, it generates this action with which you navigate from registration 1 to registration 2, and you can pass it your arguments. Okay, let's go. So in this case, what we are gonna do is asymmetric navigation. So we either logged in or we registered, but we are now logged in. So we wanna like destroy the navigation stack and go to the main exclusively. So what people used to do for this with activities, mostly because like you are already on login registration or registration 2, you cannot really tell your previous fragments to like stop existing, or at least it's not too easy. So instead what people used to do is add these flags that new task and clear task, like with this OR operator right there, like bitwise OR between these flags. And I've read that this makes you vulnerable to task hijacking if that's something that people pen test your app for. But well, technically this is how people used to do it. And in the login activity, you would say the start activity and use this intent. With Jetpack Navigation, they kind of said that you shouldn't be doing this because your start destination should be main, and then you get logged out and then go to login, and then you don't have a splash and all that, but none of that is really something you need to listen to, because what you can do instead is have a navigation tag to wrap everything in the unauthenticated screens like login and registration. And instead you want to log out of that graph, like this logged out graph. You want to pop out of it inclusively, right? Like you want to exit this graph entirely and move to this other graph where the start destination happens to be the main fragment. So as you see here, the logged in fragment defines that its start destination is the main fragment below. And of course, in the action, we also had to specify the animations again. You actually need to define this each time. And if you want to navigate back with an action, then you need to swap them up a bit. Okay, so let's see. We want to go back to the main screen from the detail and maybe even pass results, right? So what should we do here? So what you used to do to navigate back two screens, like from main to list, and then you went to detail, and then the detail wanted to go back to main without doing clear task, new task. So what would you do? What people used to do, because it was their only option, is start activity for result change. So the main would call the list activity with start activity for result, and the list would call the detail screen with start activity for result. And once you were done, you set the result to say that, yo, it's okay, it's fine, you finished, and then in onActivity result of the previous screen, you would also call finish. So this way it felt like you navigated back twice, because technically you did, but you had to make this chain, and for this you had to set up these request codes and then check for result codes. And a funny fact is that onActivity result is deprecated now, like it's actually deprecated. So instead what you need to do is use this register for activity result function, to which you pass this activity result contracts dot start activity for result, which represents the call to start activity for result. And the benefit of this is that, well, it does work across process, that's right, like otherwise it wouldn't work at all. But most importantly, it internally, like these register launchers, they are specified in a given order, and this order is used to define the request code for a given launcher. And afterwards, when you register, it checks for this ID, which is actually stable across process, that because it depends on the order in the code, but that will not change, right? Like that will not change after you restart the app. So the request codes, you no longer need to care about them, and instead you define these as a field. You say launcher.launch, and you would still need to chain them, but you would not need to care about request codes. Okay, so let's go over to Jetpack Navigation. How does it handle things? So in the detail fragment, what you could do to pass results back to the main fragment is you can expect that the main fragment exists. So in that case, what you can do is talk to a safe state handle of that nav entry and set whatever you want as a property. Another option though would be to like use a shared view model to either the nav graph or the activity, although you typically shouldn't do that because those are actually app global within a single activity application, and then you have to manually clear them. So instead of that, they have created nav graph scope view models. But in this case, in this particular example, I am using the backstack entry safe state handle because I can. And you would navigate back. So what you can do here is define this action saying that you navigate back to the main fragment. You pop up back to it, but it's not inclusive. So that way you end up on the main fragment. Okay, so this is something new. Let's see. How do we navigate with simple stack? First and foremost, what we need to know in simple stack is the backstack. It's the basis of all navigation. It's what you interact with the most. And the way it works is that it holds navigation state as a list of keys. Keys are a term that originated from Flow, but it technically represents the screen identifier. So it's an immutable screen identifier that describes what should be showing when the screen is currently on the top, for example. So the backstack by default is managed via a lifecycle observer and lives in retained scope. This is important. So the backstack already lives in the activity retained scope. It's the same scope as where view models live. And to get easy access to that, you use the navigator. You will see that later. And what's interesting and maybe unusual, I don't know, is that you get the previous and the new navigation state as a state change to the state changer that you define. So this means that when you navigate, you can define that this was your previous state, this is now your new state, what do I do now? So on this screen, we see the very basics, like the core, the most core-est part of the API, where you can create a backstack manually. You tell it what the initial key is, like you set it up with the initial keys that are provided, and then you set a state changer. Now the state change is what contains both the new keys and the previous keys, and it also gets this completion callback. Now, what's interesting here, and that's why it's bold, in this case, I check if the top new key is the same as the previous top key, because that's the case when you, for example, double tapped a button and you're going to the same screen twice, and you don't really want to crash because, well, it's a valid option, like users do it sometimes, and yeah, for example, if you were to do that with Jetpack Navigation, your app would crash unless you do some shenanigans, because it would be like, well, this action made sense on the list screen, but it doesn't make sense anymore on details, so why are you trying to navigate anyway? So if you have these duplicate navigation actions happening, then Jetpack Navigation just explodes and says, what was it again? This destination is not known to this nav controller. That's the one. Well, in this case, you can just swallow it, say that the state change is complete, just return and do nothing, and afterwards you actually handle that the key is changed. And for example, to navigate from one screen to the other, you just say backstack.go to other key, and you can even assert that the history contains exactly this key and that key, like initial key and other key. And the reason why I picked this example is because this effectively shows that the simple stack core APIs don't depend on anything Android specific, like it's mostly just parcelable stuff that it depends on, and otherwise it's, hold on a second, the view state persistence if you were to use custom views and not fragments. So that stuff is Android specific, but the core navigation logic is not. Like you can do anything you want, and you can unit test it. Like I have 280 unit tests that test simple stack, and it was not hard to write because it's like Java code. It's not Android specific. So what people are actually interested in, though, probably, is how to navigate with fragments, right? Like how does simple stack help you when you are trying to navigate with fragments? Most people use fragments now, right? So what you do is that I provide this helper called a simple state changer. It's the same thing as this basically, in that it absorbs, like it consumes the case when the state change is complete, and it assumes that the navigation action is synchronous. So in that case, what we do is that the main activity says that, okay, I'm handling this synchronously, it's fine. And what I do is create this default fragment state changer. What it does is that when it's given an arbitrary list from previous keys to new keys, then the ones that are not the top are either, well, added but they are detached, and the current new one, if it's already added but detached, then it is attached, and if it's not added yet, then it's added. So this way, without using add to backstack, like without using the fragment transaction backstack of the fragment manager, we end up creating every fragment in the state that we would normally expect it to be. And what we do is we install the navigator, which handles all this retained scope stuff and the lifecycle observing. And what we need to do other than that is handle the back presses so that we delegate it over to simple stack, like to the backstack, and handle it with backstack.goback, which is the same as navigator on backpressed. It's just helping to remember that this needs to be called. So yeah, when this happens, then we get this on navigation event synchronously. It gives us the state change, and the fragment state changer will just handle the fragment state change for us. Here, just to be like on par with the previous cases where we had to like add the animations again and again, well, there's the default in the default fragment state changer for either the forward, the backward, or the replace direction, where it slides from the left to right or the right to left, and on replace it uses transit fragment open, but this can be overridden, so that's not really an issue. And if you need anything more specific, then you can also override that configure fragment transaction function. So let's move around a bit with simple stack, right? So when you want to go from register 1 to register 2, what you do first is you create this key class, which is just a parcelized data class. It extends from either default fragment key, or you can like make your own base, but this is what works with the default fragment state changer, so that simple stacks defaults can know that you want to create a fragment with this. So this has a function that you need to override called instantiate fragment. You create the fragment there, and other than that, you need a fragment tag that is stable, which means that when you're using data classes, then I would like to use toString, but the default in the library is the class.name, like the fully qualified name, not the simple name, because that's also fairly stable. It's only when you have multiple fragments with different arguments of the same type, that's when toString really matters though. But like toString, if you are not using a data class, then it's not stable across process that, so that's why the default is the fully qualified name. Then you just import backstack, which basically calls navigator.getBackstack context, but it's practically the same thing. So you can just import it and say that backstack.go to register to key arg1, arg2, which are strings, and you don't need to bother with them any further than that. There are no string keys here, like this thing is a parcelable, right? And so you can get this key from like the argument saying that get key if you extend from keyed fragment, but you don't need to extend from it because it's the same as require arguments that get parsable args key. So basically you get the screen identifier serves as a means to type safely transfer arguments from one screen to the other. So it's very similar to like the intent extras, but there are no string keys involved. And another case where we destroy the old history, same thing, we have the main key. In this case, I still use data class. In that case, I tend to specify this noargs placeholder, but it would work even if it was a standard class. And then I call this function called backstack set history, and I give it this list, this history of main key, and say that the direction with which I expect it to change is forward. This only matters for the animation. But yeah, technically any list can be used, but history is a list that has some extra helpers. And this is my favorite because remember how we needed to pass those start activity for result chains and whatnot? Well, if you want to move to the first screen and you just say jump to root, like that basically says I want to go to the first screen and that's it. But you can also use set history or exit scope if you have a defined scope for that, but jump to roots, we tend to use that. Okay, so scoping, let's go over to scoping. Because we can theoretically define multiple scopes across this app. We have the splash screen, okay, that's independent, but otherwise we have this section that's unauthenticated. There's this one that's authenticated. We have the registration flow, in which case it might make sense to have something shared between them, because what if I get the requirement that on register 2 I insert something, I go back and forward, and the register 2's data should stay there. Like, what do you do in that case? Do you do start activity for result? Do you use singletons? Like, what do you do? And I guess most people use singletons, right? Like there are cases where this is unavoidable if you have a multi-activity app. So in that case, what you are forced to do, there's nothing else you can do, is have a base activity in which you have a static flag called is initialized and you say that it's false. And when the app is started for the very first time, then you check that, okay, so this was false, I'm trying to set it to true, but in this case, if the save instance state is not null, so I am restoring after process that, then in this particular process, I want to restore the singletons that are singletons, they exist only once in the entire process. So in that case, you need the static boolean flag, there's no other alternative. And in that case, you would need to save the state of the singleton service in every activity in onSave instance state, because otherwise there's a potential case that this activity that is currently returning to the front as the first activity did not save it and would not be able to restore it. So this is like, this is how multi-activity scoping works. In Jetpack Navigation, you can define all these navigation tags, which can each serve as one scope. And you can then scope to one of these, because each navigation block and each destination, like each node, has its associated nav backstack entry. And in the case of Jetpack Navigation, these are actually view model store owners and safe state registry owners. So you can define a view model that's scoped to it. Now, what's important here is that I did say save state registry owner because you want your view models to be able to save state across process that, so you need the save state handle. So in that case, you need it to be a save state registry owner. But if you don't have health, then you would need this helper function of sorts, where you use the backstack entry as both the view model store and you create the abstract save state view model factory yourself and use that as the save state registry owner, and pass its arguments to the save state handle to initialize its properties, like its internal map, from the arguments if they exist. That is how argument passing works. When you want to pass fragments arguments to a view model, you go through the save state handle. And then you would have to figure out how to pass your stuff to the registration view model when it's actually being created. But it's still, at least you have the save state handle, that's a start. Oh, and one thing I should mention, the default save state view model factory that each fragment and activity has, it creates the, it can pass the save state handle by default even reflectively if there's no custom factory involved, and it can also be passed to an Android view model which expects an application as a parameter as well. Okay, so scoping with simple stack, how do we do it? Because we saw how it works with view models, right? Well, the way it works is that there's this class, well, technically interface called scoped services. And in this thing, you get this service binder and you can bind services with it. that's where the name comes from. You can add services to it, service instances, and then they become managed by simple stack. So the way this works is that a key can implement either scope key and or scope key child. And what this means, scope key means that this screen has this associated scope with it, and scope key child means I have this list of parents that is potentially shared with other keys. So if either of these keys have the same string as the scope tag, then that forces this parent of this scope key to be created. That's why it's scope key.child, because this is the scope key. And I am the child of those parent scopes, right? You will see it when you see it in the next slides. So the service binder creates a scope for a given key based on the current history if that scope does not exist yet. So we have add service and lookup service. So but we have these helpers that help reduce this for you, so that you don't need to think about it, you don't need to think about scope services. Instead, you just set this default service provider, you implement default service provider that has services on a key, and then you just add your newly created instances. And what's interesting here, I even marked it with this exclamation mark, that to a view model, which by the way is a completely standard class, you don't need to extend anything to make it happen. You can pass it both the key, which as we said, contains the arguments for the given screen, type safely, no string keys involved, and you can also pass it the backstack. So this means that your view model can actually execute navigation actions without anything like a single live data or a live data event or anything similar like that. So I think that's actually useful. And so when you have this, then you find it with this, well, anyone who knows what this is a service locator, right? But it works. So you can look it up based on the type, because by default this add function uses t class java name as the default service tag. So with that we can look it up based on the type, and this works. So what's the difference between a scope key and a scope key child, implicit scope versus explicit scope, as I tend to call them? So there is the concept of the global scope, which is the parent of all scopes, but each screen can be associated with its own scope, which is scope key, and we can also define these explicit scopes like registration or unauthenticated, which is shared between these keys. But why is it called an implicit scope? What do you gain from this? Well, these purple arrows at the bottom are not there for a joke. It means that the register 2 can actually see the previous scope, like the one defined in register or even in login, because it exists before it in the history stack as an implicit parent, right? Like this was a concept in Scoop, but it isn't always sufficient, but it can actually be useful if you can guarantee that the previous screen always has to exist for this screen to exist. So in that case, this is what the implicit scopes are. And the way service lookup works is that first you go from rec2, you go up the explicit parent chain, then you go through the implicit chain, and then you check the global scope. And there is another version of this which only checks the explicit parents if that's what you need. So don't forget, what we needed to do is implement hash services. We added the scoped service to the service binder, and we looked it up. Now, this is interesting because we can pass results like this. Like in the detail fragment, we can actually guarantee that the main fragment is created. Like the main key has to be on the history stack. So we look it up. We find the main view model, and we can call functions on it. And if you don't want to see it directly, then what you can do is you can define an interface and add that. Hold on a second. So you can add that service that you added as an alias, which technically means that it's a service, but it doesn't get the lifecycle callbacks, but it can be looked up by that name. So you don't get these extra registrations for the same thing just to see it by a different name. So we rebind the list view model as the data provider for the list fragment, and in that case the list fragment can say that I want to look up my data provider. I don't care who it is. It can be anyone. So this allows you to like detach the coupling between what the view model is for the fragment. And we can also hide the result passing like this, so you don't see main view model explicitly, you just add it, right? It implements an interface, and in the detail key we rebind it. We can expect it to exist here, like this configuration matters. I added an exclamation mark, but oh yeah, there's something important there, which is that you can say lookup inside using service binder.lookup. What does this mean? Well, it tries to find in the implicit and parent, like in the parent scopes, it tries to check if there is a service registered by this name. This allows you to compose view models even from previous screens, but just in general, as these are like normal classes, you could pass them to each other anyway and just add them one by one to the service binder, and you would still get the lifecycle callbacks that we'll see. So yeah, we can define interfaces, and we can see previous things defined from the previous screen, and it's just a matter of configuration, and the fragment knows nothing about this. We can just call functions as is. So what are explicit parent scopes? You can return this list of strings that effectively describes that these two keys expect this scope to exist. So one particular approach one could take with this is that you pass back the fully qualified name of a class. This would make it be a managed service if you create it like that with that when statement below, and it would be guaranteed to exist at the right time. And it's interesting because if you have seen that when statement before over the Java class fully qualified name, then you know that you can Dagger map multibinding this if you have this, if you need to modularize. So it's technically an option to use map multibinding here, which is something I had to do once. Well, at least once, which is that we first checked if there's a provider for this from Dagger, and then we invoked that provider to get the instance instead of just directly using the constructor. And in that case, we would return this name just as well. Okay, so global services, they are pretty simple. They effectively are singletons and or activity retain global services. I usually had to replace singletons with them that are they needed state persistence. But if you have one activity, then you don't need the base activity. Instead, you could rely on it being a managed service of the global scope. So you would just add it to the navigator with set global services, and it would work. Also, we have the scope service lifecycle callbacks. Bundleable allows you to save and restore state. You have registered, which is when this scope service is being created for the first time. Activated is called when the explicit parent chain, like the top new key and its explicit parent chain is the new top. So in that case, the activated callback is called, and when that changes, then they become inactivated. This is very similar to onStart, onStop, but it doesn't depend on onStart, onStop, just on the navigation history. And there's one more, which is handles back. The view model can intercept the back handling using this onBack event. If you return true, then it says that it's handled, so it doesn't try to navigate back to a previous screen. If you return false, then it falls back to the default. This, of course, happens also across the current active explicit parent chain. So there you have it. You could have a registration view model that can implement these interfaces. If it's added to the service binder, these will be called as expected. And in that case, you could have a composite disposable inside. You can say composite disposable clear in on service unregistered. It works just like view model on cleared. And you can also return the state bundle, save and restore state from it with these simple callbacks. What about process that? Well, if you return on the detail screen, then the main view, like the global scope services, the main view model, the list view model, and the detail view model, they are all recreated in this particular order, because otherwise the service lookup wouldn't work. Like you could not depend on the existence of these services, because why would they exist? Well, in this case, you don't need to be in the fragment and then invoke the lazy, because the backstack recreates them. It's part of the core behavior. So this way, this inheritance, but not really inheritance, this composition of view models is possible even across screens if you want it. So we actually handled all of these things because the backstack retains the screen state. It handles back. You can move between screens. You can pass arguments as keys. You can animate the fragment transitions. The navigation state survives config changes because the navigator installs the backstack host which survives this. The uservive process that because that's also handled automatically. Especially with default fragment keys, which are parsable by default, so you don't even need a custom key parser or anything. It's the default behavior. It works. You can communicate between screens and even pass results using either the implicit scope mechanism or even hide them as behind interfaces. This is technically unit testable to see that if this screen is on the history stack, then lookup works because, well, it's all not Android specific. You have screen lifecycle bound classes. You get all these nice callbacks like on service registered when this service starts existing, on service activated when you actually navigate to that screen, and you can even share data, right? So this is the bonus. Hopefully we have some time for it, question mark. But Jetpack Compose, what about it? Because it completely changes things, right? Well, kind of, but not really. So it's a new declarative UI framework by Google, where what's important to know about Jetpack Compose, and this is super important, is that each code block is identified with a unique ID based on where it is in the code. Like an if statement changes this, a function invocation changes this, a for loop has its own ID. So the recomposer hash is dependent on where you are in the code. This is why they actually analyze your code for the composable functions. So when your arguments change, like your function arguments change, or your variables that are wrapped in states are changed, then this causes a recomposition. And because of that, you cannot really guarantee when recomposition happens. So any state changes, like including navigation, should not happen as part of the definition of this composable hierarchy. It needs to be either within a callback or within an effect. And the way to think about it, I think, at least, for Compose in regards to how it's a declarative UI that defines what exists right now. Well, what is called does exist, and what is no longer called no longer exists. The way we can detect that something starts to exist is with this disposable effect unit block. This is how you can define that this composable exists, so I want this registration to exist. So in that case, you use this disposable effect, and in non-dispose, you cannot register. This is important for us because Compose has this concept of the saver framework, which requires a remember savable state holder to exist, which can detect when your composable no longer exists, and in that case it saves its savable parameters, like anything that is wrapped in remember savable. And what's also important here, it's really like a just a bonus to know, you can use this fast for each, which when you are recomposing, then it doesn't allocate an iterator, so it's better for compose. And as I mentioned before, a loop has its ID, and an if has its ID, but within the loop, you need to identify uniquely what this currently is. So in that case, you invoke this key function, you just pass it this thing, it basically just calls content, whatever you pass it, and this creates a new unique but identifiable ID for the elements within the loop. So what about config changes? Because we have remember savable, but that saves across process that, right? Well, we need the activity retain scope for that, but who tracks it? Because Compose sure doesn't, right? Like unless you block them, but that wouldn't happen. So one particular option is navigation compose, in which case you would remember the nav controller, you define the navigation graph within the nav host using these string keys for each route, where a composable has a string identifier, a navigation block has the string identifier as well for which composable to show first, and what you need to pay most attention to is that to pass arguments, you need to make it part of the string definition, similarly to a query string syntax, where you need to manually concatenate the arguments and then define each type for this thing that is passed in as a string, because this is a query string, right? So you manually need to say that this was actually an int before, so that the bundle would actually retrieve it as an int instead of like pass it directly in as a bundle. As a string. And what's also important to know about this is that this particular mechanism expects direct serialization to string, which means that parseable and serializable types are not supported by navigation compose when you want to navigate and pass these types of arguments. That includes enums and any parcelable classes. So you get the nav backstack entry, which contains the arguments. You can get the stuff from them because, well, the arguments are basically a bundle. And what navigation compose does, it defines this nav backstack entry as the local viewModel store owner. So if you use viewModel, which is not by viewModels, to get the detail viewModel, then it would scope it to the nav backstack entry that is currently being created. And below you can see that you can consume double events by checking the nav backstack entry's current lifecycle method, saying that if it's resumed, then it's okay to navigate, and you need to manually concatenate and or convert the types to actually define this query string syntax. So on the other hand, you have simple-stack compose integration with this kind of beta, but less so because tomorrow compose is coming out, or so they say. And in that case, you create this compose state changer, you pass it to the async state changer because we need to asynchronously handle the case as you are moving from one state to the other so that animation becomes possible, because currently Navigation Compose does not support it, but they are working on it. Yeah, so another thing you need to specify here is the backstack provider to which you pass the backstack you get from install. This allows you to see the backstack within the composable hierarchy, and you would handle backs just like you did before. So in this case, what you do is you use the default compose key. It's not parsable by default, but it might be because eventually we'll see. But it is used as the savable state provider key, which expects it to be immutable. So in this case, we define this detail key, we pass it the arguments as strings, typed of course. And what's super nice is that as we see, as the definition of the screen is within the key, we can directly pass these arguments as strings. There is absolutely no conversion involved. You just pass it. And in the screen itself, like the composable screen, you can get the backstack from a composition local, which is what the backstack provider sets up for you. And in that case, you can just call backstack, jump to root, our favorite function, in any callback as you would expect. So now what we can do, you can also combine this with default service provider has services, define a login view model, make it survive configuration changes, like have your data sharing set up, your result passing set up, you pass it the backstack so that it's able to navigate. And we use this remember service method, but it's really just remember backstack lookup. So it's nothing too special. And to the screen, we can just directly pass function references to the view model methods. This way we don't need the screen to know about anything except that something happened. So in the login view model, we get the backstack like we did before. We can navigate just like we did before. We can even handle back here just like before. And we have safe state persistence, and we are not forced to use safe state handle get live data. You can use anything you want. For example, my choice here was behavior relay. You can just save the properties from it into a bundle and then restore it. Something I didn't mention before, state bundle is a parsable, but it's not a bundle, but it works just like a bundle. The reason why that is so that it becomes unit testable. Like you can actually instantiate it, as make a sessions for it, all those things without mocking. So we are reaching the end. We have the links to the library, which is composed of those three things. We have some links to articles, and thank you for your attention. Q&A.
I think we have 2 questions.
Oh,
Gabor?
2 questions. Okay, let's go.
Yeah.
Can you share the repo for that sample in the slides if it exists? It's a combination of 3 different ones, but I will. I will. So hold on a second. Let me grab it. Like, do you need the compose one or the other one? Or both? Like, it really is from 3 different repos. We'll see. Deep links. Okay, so the trick to deep links is that in activities, you need to define the activity task stack builder, and you build a new activity task stack manually and replace whatever you currently have. In the case of Jetpack Navigation, you can define deep links, but they're a bit esoteric and I haven't really used them. That's why I didn't include them, but theoretically they work. And in the case of simple stack, you can use backstack set history and redefine your history to whatever you want. So I didn't really focus on it because it's the same as any asymmetric navigation where you want to destroy your current history. So that is answered. Is there a connection to Android App Service? None. There is absolutely no connection to Android App Service. I just really couldn't come up with a better name for a scoped service because, well, it's not really a view model. Like I called it view model throughout because it's familiar, but I mean, it's just a class that's like screen bound. So I could have called it screen bound classes, but that clearly sounds worse. So yeah, it doesn't have anything to do with Android app service. Can we get simple stack compose for KAM? That's the $1 million question. If you know how to like host a KAM library without it being on Maven Central, then I will do it. But because, well, as I said, only view state persistence is in for specifically for custom views, and parcelables are bound to Android, nothing else. So most of the logic is already independent. So, but to rip those out, I would need to effectively create a new version that would be almost the same, but it's KIM and it wouldn't have views. So I would do that, but I don't know a way to host it without it being Maven Central, and I don't really want to put it there. So I mean, I could, like, if enough people ask for it, I will, but currently it's on Jetpack because it was much easier at the day. I did not have the domain for zuinden.com. Now I do, so that's great. Yeah, so these are things. I think these are so far answered. Are there any solutions to duplicate arguments in source and destination using graph other than using simple stack? There's the Kotlin DSL where you can, but with the XML, no. With the XML, no. You need to duplicate it to every single action that navigates to that fragment, and you need to duplicate it to the fragment. And if that fragment is the start destination of a navigation tag, then it also needs to be duplicated to the navigation tag, if I recall correctly. And there's no way around it. None. That's how it works. Yeah, so that's the answer. I would rather use simple stack in your case because it's less error prone. Why not just use fragment transactions? I am using one fragment transaction behind simple stack. It's what the default fragment state changer does. Like that's what it does. And the reason why is that you don't need to think about it. Like you just say, go to this other screen and it works. You get these automatic like argument passing that is type safe. You get the data sharing between view models using either implicit or explicit scopes. You get the lifecycle callbacks. I think it's pretty cool. It's a good deal. So yeah, that's why, like, you can use fragment transactions, but you know what that tends to end up looking like? You tend to end up with like touching the fragment manager from inside an adapter. Like, just this is better. This is better for you, I promise. When is stable compose getting released? Supposedly tomorrow, or so I heard. They bumped it to 1.0.0, so it might happen. It might happen. And great talk, thank you very much. I think I went slightly above 30 minutes, but hopefully you still enjoyed it.
Yeah, thanks a lot, Gabor, for the wonderful talk. And any relevant links, I think we'll share. We also have a recording for this, which we will put on YouTube real soon. So thanks everyone for joining. I think we have another talk in about an hour. So feel free to take a break or hang around the tables, and we will connect soon. Yeah. Thanks everyone. Thanks, Gabor.
The pleasure is mine.
Thank you.
Thank you.